Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about the common base of logarithms. In the previous videos we've talked about logarithms with a variety of bases, and we can use pretty well any number for a base for logarithms as long as it's positive. So that's one thing I wanted to emphasize. Your bases for logarithms must be positive. You can't have negative bases. And because your base is always going to be positive, whenever you take a positive number and raise it to an exponent, regardless of what that exponent is, the quantity will also be positive. So therefore your quantity will always be positive. The only thing that's allowed to be negative is the exponent, or in other words, the logarithm. So the logarithm, the exponent may be positive or negative. But there are two bases that we use extensively when we're looking at logarithms. When we look at using logarithms to solve certain types of equations, and when we look at applications of logarithms in different technologies and different applications in science. So we're going to study one of those bases today, and it's called the common base. And common base means base 10. When we write our logarithm with base 10, we actually don't put the base in 10. So when you see this, understand that it means this. So this is our notation. We're going to talk about calculators today. Because we're going to use your calculator to find the logarithms of different quantities. So on your calculator you will have a button that looks like that. It says log on it. And when you see that, understand that it's only base 10. It doesn't work with any other bases of logarithms. Only base 10. So this is what we're going to use, and we're going to take a look at finding examples of logarithms. And then we're also going to do the reverse and find what's called the antilog, base 10. So let's get started. I've written different powers of 10, from 10 to the negative 4 to 10 to the 4th power, and we will use this as a bit of a guide to just do a check when we do find these logarithms, or to do an estimate before we find the logarithms. So let's take a look at these examples. Log of 250. We know that 250 is between 100 and 1000. Therefore, our exponent should be between 2 and 3. It's a good idea to have that understanding and think about it before you punch it in. So if we do this, punch 250 log. Some of you will have calculators where you have to do the log function first and then your 250. You should all, just try it on your calculator, you should all get the result of 2.398. I'm going to round all of these off to 3 decimal places. There are certain rules that you should be following in terms of significant digits, but we're not going to worry about significant digits in this video. That's going to be a separate video where we talk about how you know how many digits to write down. For now, let's just round all of these off to 3 decimal places. Let's try the next one. The log of 1400. Again, 1400 is between 1000 and 10,000. So we know our exponent should be somewhere between 3 and 4. Think about what log means, and then we know we're working with base 10, so it makes it fairly easy compared to other numbers. And then have an idea. We know that I should get an answer. I should get an exponent somewhere between 3 and 4. And I do get 3.146. Let's continue on. Log of 15. 15 is between 10 and 100, so my exponent, or my log, should be between 1 and 2. Punch it into the calculator, and we get 1.176. Next one, log of 2. Again, let's determine approximately what our exponent will be, our logarithm will be. 2 is between 1 and 10, so our exponent should be between 0 and 1. We punch it in and we get 0.301. Now when we get into values that are less than 1, we're going to encounter negative exponents. So 0.3 is between 0.1 and 1. Therefore, my exponent should be between -1 and 0. We punch it in and we get -0.523. Hopefully you're getting these results on your calculator as well. Our last example, 0.04, is between 0.01 and 0.1. So our exponent should be between -2 and -1. Punch it into our calculator and we get -1.398. So understand, when you are using your log button, it means you're working with base 10 and you're finding the exponent to which 10 must be raised to equal the number that you're finding. Practice some of those, get comfortable with that function on your calculator. These numbers can be as large or as small as we want. They can have as many decimals. It really doesn't matter. The only thing that you will not see is a negative value. Your quantity cannot be negative. Because your base is positive, your quantity is going to be positive. So if you ever try to find the log of a negative number, your calculator will say error. You shouldn't be asked to do that. Now, we're comfortable hopefully finding the logarithm or the exponent when we're working with base 10 using that function on our calculator. What I now want to talk about is antilog, which is the inverse. Let's just review exponential notation, but this time we're going to work with base 10, so we don't write it. If I see x equals the log of q, so far we've just been finding x when we knew what q was. So we know the quantity, we're finding the exponent. If I were to write this in exponential notation, my base is 10, my exponent is x, my quantity is q. So 10 to the x is equal to q is the same relationship as x equals the log of q. And in many instances, you're going to be asked to find the quantity when you know the exponent. When you're asked to do that, you're finding the antilog. And the antilog function on your calculator looks like this. A lot of students mistakenly use this when they're entering numbers in scientific notation into their calculator. They use this 10 to the x. If you do that, like if you had a number 4.23 times 10 to the 4th, if you tried using this key to put this in, you're always going to be, your decimal point is going to be in the wrong place by 1 place. This is not intended to enter numbers in scientific notation. You have another function on your calculator for that, but it's either EE, EEX, or EXP. That's what you would use for entering a number in scientific notation into your calculator. This is the antilog function, and the only time you'll be using it is when you're finding antilogs, base 10. So for example, if we knew that 3.12 was our x, and we wanted to find q, what we could do is rewrite it in exponential notation. So I know that I'm going to be finding 10 to the 3.12, and that will give me q. So I'm not finding the log of 3.12, I'm raising 10 to the 3.12. And in order to do that, I use my antilog function. This function may be the inverse function of your log function. It probably is. So you're not going to find a separate key. You might. I mean, there's so many different styles of calculators. But above the log function on your calculator, you will probably see the 10 to the x, and it will be the inverse of that function. So then you're going to have to press your inverse function and then your log key, which gives you the antilog 10 to the x. When we do use this and find 10 to the 3.12, we will get, before we find it, let's talk about 10 to the 3 is 1,000, 10 to the 4 is 10,000. So we know our number is going to be greater than 1,000. Our quantity is going to be less than 10,000. So again, have that understanding, have an idea of what to expect so that you can catch any errors. So plugging in 3.12 into our antilog function, we will get 1,318. I'm only going to go one decimal place here, 0.3. Okay, try that on your calculator and see if you get the same result. And then let's do some more examples of these. You might be asked in this way, find the common antilogarithm of the following. Common tells us it's base 10. And they might just give you a set of numbers like this. Or they might ask it like this. 0.4 is equal to the log of Q. Find Q. So, you know, there's different ways that you can be asked for the antilog. In both of the way that it's asked here, it means what we're finding is 10 to the 0.4. That's what we're finding. We know that 10 to the 0 is 1. We know 10 to the 1 is 10. And 0.4 is between 0 and 1. So we know that our answer should be somewhere between 1 and 10. So we use our antilog function on our calculator, 10 to the x, and we should get 2.51. Okay. Same thing here. I could be asked to find the common antilog of 1.45, or I could have 1.45 equals the log of Q, or whatever the variable is. Find that variable. So what I'm finding here is 10 to the 1.45. When we punch that into our calculator, we get 28.18. Well, we know that 10 to the 1 is 10. We know 10 squared is 100. So it makes sense that an exponent between 1 and 2 would give us a quantity between 10 and 100. This next one, we're getting into negative exponents. It's the only time you'll see negatives is with exponents. And again, we know that 10 to the negative 2 is 0.01, 10 to the negative 1 is 0.1. Negative 1.7 is between those exponents, so our quantity should be between these quantities. We punch it into our calculator using that key, and we get 0.02. The last one I'm not going to even use a calculator for. Whenever you have an exponent that's just an integer, you can leave it in that form, or without a calculator, you can write that as its decimal value. Practice using your calculator, getting comfortable knowing when to use the log function and when to use the antilog function. In the next video, we're going to talk about another base for logarithms, the natural base. Until then, take care.